Okay, here we are at the last video of the unit, and this is really a put it all together um, video where we're going to look at just messier, more complicated shapes and ask those same questions. What's the surface area and what's the volume? And I'm just going to go through one example, and in class we're basically going to do a bunch. So a composite shape is a shape made up of more than one other shapes. So the example below is an example of a prism on the bottom and a pyramid. So we see a prism and a pyramid. And prisms are not really that much of a big deal. Pyramids, again, we got to worry about slant heights. We have to worry about different slant heights. We need to worry about heights and things like that. So they're a bit more trickier. So the first thing we want to do is, I'll give us the dimension, and the dimensions are all in meters. So 6.7 meters, 2.9 meters, 2.9 meters. And I'm going to tell you that the height of this thing, the height of the prism, not the height of the entire object, but the height of the prism is 2.1 meters. Okay, and what we need to find then is what's the surface area and what's the volume of this entire thing. Volume is, I hope you guys have recognized, is a lot more straightforward. So if we're going to figure out the volume of this, I'll call it volume total is equal to the volume of the prism plus the volume of the pyramid. And again, it's a really good habit to get into volume formula. Well, volume formula of a prism is LWH, and the volume formula of a pyramid is 1/3 LWH. And in this particular example, it would be 6.7 times 2.9 times 2.9. Now remember, one of the things we have to remember in the prism is that this particular h here represents the height of our prism, or the height of our pyramid, sorry, and this one here represents the height of the prism. So again, in this example, these two heights are not the same, even though the formulas look alike. So our length of our base of our pyramid would be 6.7. The width of our pyramid would be 2.9, and the height of our pyramid would be 2.1. And when we plug all of that nasty mess in our calculator, we get 69.9 cubic meters. So again, pretty straightforward. And as I mispronounced a couple of times there, pyramid and prism, prism and pyramid, that's why it's a really good idea to write things out. Things get confused in your head, at least they do in my head. And when you write things down, you either catch yourself or you really understand what you're talking about. Okay, so let's go to surface area then. Well, surface area becomes, well, we could look at this and go, okay, let's figure out the surface area of the prism. Again, there's never any problems with that. And after that, we'll worry about the pyramid. Well, one of the things I want you to notice, unlike the prisms we did before, this thing doesn't have a top of a prism, really, because the pyramid is right on the top. So when we figure out the surface area of the prism part, notice we have a front and a back, a left and a right, and we do have a bottom, but we don't have a top. So in doing that, what we have is we have the area of the front, which is 6.7 times 2.9, and of course there are two of them. And then we have the sides, which is 2.9 times 2.9. And again, there's two of them. And then finally, we have the 6.7 times 2.9, and that is the bottom. And again, if we color coded these, okay, I'm going to call this I'm going to call this 6.7. I'm going to call this one 2.9, and I'm going to call this 2.9 blue. Well, in doing our bottom, what we have is it's that one. Of course, our 6.7 is always that. And in figuring out the left and the right, well, this 2.9 is the one on the bottom, and this 2.9 is the side. So again, a nice way of keeping track of what you're multiplying is somehow identifying them, color coding them, whatever. A really good strategy. And when we figure out what that is, then it ends up to be, well, I don't know what it ends up to be, because I've added everything up. So let's kind of hang on to that for a sec. Okay. What's the surface area of the pyramid? Well, again, when we're doing the surface area of the pyramid, that's a little bit problematic because we have the base. The base of each face is either 6.7 or 2.9, the highlighted yellow or the highlighted green. What we really need to do is to go, okay, well, what is this slant height? And I'm going to call that one, we'll call the red slant height B. So there's my red slant height. And I also want to know, we'll call it the green slant height, and I'll call that my A. And in order to do that, we have to use the height of the pyramid to determine the slant height of those imagined inside right triangles. So let's do the first slant height first. I'm going to draw my cutaway of my right triangle. And what I know is that A is the slant height. I know the triangular height is 2.1. And I want to know this distance right there, which matches this distance right there, and that's half of 6.7. That is 3.35. And when I do all my Pythagoras, a squared is equal to 2.1 squared plus 3.35 squared. A squared is equal to, I did do this calculation, 15.6325. Remember, 4 decimal places. And finally, taking the square root of both sides, we get A is equal to 3.9538. So there's the slant height of that. And again, I need that to figure out the area of that triangular face. Okay, let's do the same thing with B. So again, here's my sketch of my right triangle. We know B is the slant height. We know the height of that triangle is 2.1. And in this particular example, I need to figure out that distance right there, just imagining it. So that's half of 2.9, which is 1.45. And when we do this calculation, B squared is equal to 2.1 squared plus 1.45 squared. B squared is equal to total 6.5125. And again, square root both sides, and we get 2.5520. Now, given that we've figured this out, what we can then do is use those calculations in figuring out the surface area of a pyramid. Remember, it's triangle. So if we looked at, let's look at the front and back face where I have my red slant heights. So the formula is 1/2 base. Well, the base of that is 6.7, and our slant height is 2.5520. And recall, there's two of them, front and back. Then we have our left and right. So we have two of those times the formula 1/2 base, which is 2.9, times the slant height, the height of that triangle, which is 3.9538. 3.9538. So when you put all of that mess, and again, you could do this as you go along. So the surface area total is equal to the surface area of the prism, which is this right here, plus the surface area of the pyramid, which is this right here. So you've either figured that beforehand, or which is probably a better idea, or plugging it all into your calculator, and either way, we're going to end up with 103.7 square meters. Now these things get messy, and it's all these attention to detail things that I've been talking about. So one of the things that I want you to make note of and be prepared to talk about at the beginning of classes, any ways that you have that help yourself organize messy problems like this. I've done a few examples. I've shown all my work. I've used different colors. I've highlighted. I've labeled the dimensions. Do you do something else?